For the very first time, we're looking at the derivative of an inverse trigonometric function. So first, we will start off with calling it as y is equal to sine inverse of x. What we know about sine inverse of x is, well, it's an inverse trigonometric function of our sine. So what I can do is, taking sine on both ends, I can take sine on both ends. And so this will be sine y, sine of sine inverse of x, so on and so forth. So we'll end up with sine y. Function and its inverse will give us back the input value. So this is equal to x, right? So now we have to find the derivative of this. So this is where your new concept of explicit function and all of that comes into picture. Implicit and explicit and all of that. Now, how do you differentiate this? So we are going to differentiate the given expression or equation with respect to x itself. Taking or differentiating the above equation with respect to x. So differentiate sine as sine. So that would be cos. So whatever the variable is, that. And using our chain rule, we'll end up with dy by dx. Think of it. So there are two things over here. One is sine as a function and y itself is there. Y is dependent on x. So y itself has an expression on it. So we need to take a derivative of y also. So if you're thorough with chain rule, this will make sense. And the derivative of x is 1. Right? So derivative of x to the power of n is n into x to the power of n minus 1. With that, this is 1. So we are looking at dy by dx is equal to 1 by cos of y. Of course, we need the answer in terms of x. But x is equal to sine y, not cos y. How can I express sine y or cos y in terms of each other? We are going to make use of cos y. Think of it, it's not that hard. Yes, root of sine square y. So we have dy by dx is equal to 1 by square root of 1 minus sine square y. And finally, when we substitute from 1, we have square root of 1 minus x square. Substituting from 1. Right? Okay, so derivative of y is equal to sine inverse of x, or derivative of sine inverse of x is 1 by square root of 1 minus x square. So let's look at the domain value, that is what set of values will make sense over here. So the domain value will look like square root of 1 minus x square being greater than 0, right? So this is what it depends on. Because this particular expression has to be greater than 0, if not, things will not work out. It can't be equal to 0 because this expression is in the denominator, so it can never be equal to 0. And this expression has to be greater than 0 because it's a root. So we can tell from the above expression, above equation, we can infer that root of 1 minus x square has to be greater than 0 because we are looking at real numbers. Now, squaring both ends, we get this expression. A bit of rearrangement, we get this expression. So basically, we are telling x square has to be less than 1. When is this possible? When do we have x value which is going to lead us to a value which is less than 1. Any value between -1 and 1, right? So basically we end up with decimal numbers. Does it make sense? So only then this particular equation will make a sense. If I give any number more than 1 or equal to 1 also, this will be infinity more than 1. We'll get a imaginary number which is not the one which we are looking for. So your domain will remain to be this. Again, this is all knowledge that we need to derive. Just don't by heart all of this. So derive yourself, it's not too hard. Okay, you can do the same thing with cos inverse, tan inverse and all of it. I'll add few more. So rest of it is on you guys. Okay, find the derivative of the given function and also find the domain. And you can cross verify. All the data is there in your book and in my concept map as well. Okay, now pause and have a look.